Okay, so I have shared my whiteboard. You guys would be able to see that in some time. Yes, Munja, are you able to see the whiteboard?
Yes, ma'am. Thank you.
All right, okay, you're welcome. Okay, so today we will start chapter number seven, that is the most important chapter, that is differentiation. Okay, let's understand what differentiation is. And once we are clear with the concept, once we know what exactly differentiation means, then we'll see how to do that. Okay. But before that, I'm not going to talk about how to do it. It's important to understand the concept. Okay. First thing is that differentiation, derivatives, gradients, slope, all these are the same thing. So I'm pretty sure that by now, since you guys are done with your O levels, you must be knowing what gradient is. Gradient is the slope, right? We know what slope is, we know what gradient is, so that is differentiation. Now, let's talk about a simple example. I'll make a graph. Let's say this is a line and it is passing through this point, that is the origin. So it has the coordinates 0, 0, and we have this point, let's say the coordinates are 3, 3. How do we find the slope, or how do we find the gradient? So we use the formula m equals y2 minus y1 divided by x2 minus x1. We can think about first point as any point, and the answer is going to be, it would be 3 minus 0 divided by 3 minus 0, and it would be 1. Okay. This is how we used to do in O levels, okay, in order to find the gradients. And we know we can only use this formula for a straight line, okay. We have the formula, we can use it for straight lines only. So you can easily find the slope of, let's say, this line or this line. And we know that if we have a horizontal line, the slope would be 0. If we have a vertical line, the slope would be infinity. We are comfortable with these concepts, right? Okay, that is good. That is the old knowledge which we have. And this is how we have been finding slopes and the gradients. Now, let's talk about AS. Let's see, why is differentiation important here. Let's say you have a curve of this type, and you are interested in finding out the slope at this point. Now, in order to do that, how do we do it? We make a tangent line at this point. What is a tangent line? Tangent line is a line that is touching the curve at this point only. So I am going to, let's say this is the point, since the graph is not smooth there. Let's say this is the point, okay? And I'll make the tangent line now. So this yellow line is basically the tangent line. This yellow line is touching the graph at one point only, and this is the point, okay? Now, in order to find the gradient at this point, we cannot use the curve. We need to use any 2 points on the tangent. Now, since the tangent is a line, and we can use the formula m equals y2 minus y1 divided by x2 minus x1, right? Okay. But that is going to be very, very time taking, and that won't be exact. Let's say this is the point. Now it could be that, your tangent lines are not that appropriate. Let's say some of the students are making it this way. Then let's say we have some students who are making it this way, because obviously we are doing it with our hands. So it could be that we make a wrong line, right? So this method is not that good one. So that is why we use differentiation. Okay. And how is differentiation used here? I'll tell you. So what was the task? The task was, the end thing is to find the gradient at, let's say, any point on this maroon curve. Let's say this point. let's say this point, let's say this point. Now I want to find the gradient on multiple points, and this is y equals x square. Okay, this is the equation of this curve. This is the y-axis, this is the x-axis, and I am interested in finding out the uh, gradient or slope on all these pink dots which I have made. Now, how do I go about it? The best way is to find the derivative or to differentiate this curve. I have told you already all these terms are same. So at times I would be using derivative, at times I would be using differentiation. They are exactly the same. Okay. How do I do it? Step one would be to differentiate the equation of the curve. We will always be differentiating curves. We don't need to differentiate a straight line. We can find the gradient using the formula. But we know that the gradient on a curve is different. On this point, the gradient is different. On this point, the gradient is different. At this point, it's different. At this point, it's different. So I know that on curve, the gradient keeps on changing. And step two is, now step one was to differentiate the equation of the curve. I did not talk about how to differentiate it. Just know, once you will differentiate it, you would get an expression that has x in it. Okay. So you are going to use that, use the x coordinate of the point to find slope slash gradient at that point. Okay, let's say this is the point and it has the coordinates x is 2 and obviously y would be 4 because it is x square. So this point is 2 and this point is 4, and I am interested in finding out the gradient, the slope at this red dot. Okay, so how do I do it? I will find the derivative of the equation. For now, I'll just write it down and I'll tell you how to do it. Okay, I'll tell you how to do it. Do not worry. This is how we denote derivative, dy by dx. We denote gradient using m. We denote speed using, let's say, s. We have different, symbols, different things for denoting different things in maths, right? We denote percentage with this sign. So in order to find the derivative, this is how we write it down. Dy by dx in this case would be 2x. I did not tell how, I'm just telling it would be 2x. I'll tell you how it is 2x. I told you in the very beginning. Initially, we will not talk about how to find the derivative or how to differentiate. We'll just talk about the application of this thing and then we'll see how to do it. Okay. So it is dy by dx. So the answer of step one is dy by dx equals 2x. And what was the goal? The goal was to find the gradient at this point. Now I'll plug in the x coordinate at this point, that is 2. So dy by dx, that was 2x. And once I plug in the x coordinate, instead of x, I'll write down 2 and it is going to become 4. This 4 is the gradient or the slope at this point, right? So instead of making that line and picking up 2 points and then using m equals y2 minus y1 divided by x2 minus x1, the best way is to take the equation, differentiate it. I'll tell you how to differentiate it. Once you have differentiated it, if the examiner wants you to find the exact derivative or the exact gradient or slope, only then you will plug in the value of 2. In most of the questions, you will just leave the answer like this. Okay, so this is basically the basic idea about differentiation. I'll repeat it one last time. Some of the students have joined late, and then we will talk about how to differentiate exactly. Okay, now we are on the seventh chapter. This is one of the most important chapters in our syllabus, and that is differentiation. Okay, differentiation, derivatives, gradient, slope. These four terms are exactly same. Okay. Now in O levels, we have been talking about straight lines, and we know how to find the gradient and the slope of that straight line using the formula m equals y2 minus y1 divided by x2 minus x1, right? But instead of a curve, we know that the gradient keeps on changing. For example, now I'm using a black pointer. The gradient at this point is different. The gradient at this point is different. The gradient at this point is different. So in case of a curve, the gradient keeps on changing. One method of finding the gradient or slope at any point is to make the tangent line. And then since this is a line, let me just make it look like a line first. So let's say it should be touching the curve. So let's say this is the line, okay? So I'll pick up any 2 points. So let's say this is the point on the line, this is the point on the line. Now this black line, this line is the tangent line. I know how to find the gradient of a straight line using the formula, the m formula. M equals y2 minus y1 divided by x2 minus x1. The gradient of the black line and this point would be same. So one method is to make the tangent to find the gradient and say that the gradient at this point would be same as the gradient of the tangent. But that method is an old method. We used to use that method when we did not know what differentiation is. Okay. So far, we did not talk about how to differentiate. The only thing I've taught you is that once you have your derivative, let's say this is the equation and this is the derivative. If you plug in the x coordinate, you would get the gradient or the slope at that point. For example, if I talk about this red point, the x coordinate was 2. When I plugged in the x coordinate, I got 4. And this 4 is basically the gradient or the slope at this red point. Anything that you did not understand so far, please feel free to ask me. Yes, Munja, Haris, Ashal.
I'm still with you, ma'am.
Okay. Ashal is saying got it. And what about you, Haris? Are you there? Okay, perfect. Okay, so you guys are clear with this, okay? Right. Now I am going to rub the basic idea. You'll see this discussion was very important, and we will come back to this discussion after a while. Okay, now we'll talk about how to differentiate, and then we'll see why was this discussion important. So I am going to rub this thing and this as well. And now we will start the chapter formally with the very first formula. So maths is all about formulas, and we will see how to use them. Okay. The very first formula is basically the differentiation of power functions. Okay. Let me just write down the formula and then I'll explain the concept. So this is basically the differentiation of the power functions. And the formula is d okay. Now forget about whatever I've written in the pink box. Okay, I'll refer to that later on. For now, let's just talk about this one. Now I'll tell you what differentiation is. Now we know what differentiation is. Differentiation is basically giving you the derivative once you plug in the x coordinate. Okay, how to differentiate? Now that is the topic. Now let's say you have y equals f of x, and that is x to the power n. Okay. Now this is the equation of a curve and you need to differentiate it. Okay. Now this is a general idea. I've written it this way, y equals f of x, because at times you will see it this way, y equals x to the power n, and at times you will see it this way, f of x equals x to the power n. Okay. So you guys know this already, that we can define the equation in any way. Most of the time you'll see it this way, y equals x to the power n, but it could be this way as well, right? So just try and get comfortable with those. Okay. So let's keep it this way for now. Let's say y equals x to the power n is the equation of any curve. What is n? N is a constant number. N could be 1, it could be 2, 3, 4, 5, 6. N could be 1 by 2. N could be minus 1, minus 2, minus 3. N could be minus 1 by 3. N could be any number in this world. Okay. N could be any number in this world. For example, the equation could be y equals x square. We have seen that that makes a parabola. It could be y equals x cube. So we know we also have cubic equations. It could be y equals x. That is a straight line. It could be y equals x to the power 1 by 2. It could be y equals 1 by x. So when I say 1 by x, that basically is x to the power minus 1, right? It could be y equals x to the power minus 2. Now, what are these? All these are different types of equations. And the formula that I've written above is used for all these types of equations. So how do we do it? Okay. So first thing is to write down dy by dx. This is just a notation. This is how we denote differentiation. Okay. Dy by dx means the derivative of this equation, that is y equals x to the power n. Okay. How do we do it? We take this power and we write it down next to the number. So it would come here. It is n. Then I'll write down x as it is, and the new power would be n minus 1. Okay. So this was the power. I've taken that over here, and the power in case of the derivative would become old power minus 1. For example, let's say I'll start with very basic examples and then I'll get to the complicated ones. So let's say I have y equals x cube and I am interested in finding out the derivative, or I'm interested in differentiating this equation. The wordings could be different. The idea, the method, the solution is same. Okay. So again, step 1, dy by dx equals this number, that is the exponent, that is the power, comes right next to x, 3x, and what would be the new power? Old power minus 1. So that would be 3x squared. Now this was the first example. Let's say I have another example, y equals simple x. Okay, so what would be the derivative in this case? It would be dy by dx. We don't usually do the differentiation in this case in order to find the gradient, because we know y equals x is a linear equation and that gives us a straight line, and we know how to find the slope of a straight line using the simple formula. Okay, but this is equally easy. In fact, I would say this is more easy. So this is going to be, what is the power? The power is 1. 1 would be written next to x. So 1 into x, old power minus new power. So that would become 1 into x to the power 0. And this is 1. Any number to the power 0 is 1 basically. So I have 2 messages. Okay, very good. Haris is saying 1. Okay, Ishal, it would be 1. Oh, yeah, okay. That's okay. That's okay. So any number to the power 0 would be 1. Very good. So this means that you guys are understanding this. Munja, are you okay with this?
Yes, ma'am.
Okay, perfect. Now, what did I write in the pink box? The pink box is exactly the same thing. It is the very first formula of differentiation, and that says if you have x to the power n and you have been asked to differentiate it, find the derivative, whatever you call it, how do we do it? You take n and write it down next to x, and the new power would be old power minus 1. So old power was n, you do n minus 1, right? This is the basic formula of differentiation. Now we will talk about some questions, then you see how to do it. So I'll keep the formula there and I am going to talk about the questions. Okay. And trust me, differentiation is very easy. Okay. If you will tell yourself that it's difficult, obviously you'll think about it as a difficult concept. But being a teacher, I'm telling you, this is one of the most easiest and one of the most important topics as well. Okay. Because these are the basics for many other questions. Okay. Anyways, example number 1. This is the formula. Example number 1 is y equals x to the power 7, y equals 1 by x square, y equals under the root x, and then the last one is y equals 2. So we have these 4 examples. I want all of you to try the first one and then I'll tell you how to do the next 3. But just try the first one, please. Try finding out the derivative of y equals x to the power 7. The formula is written in the black box, okay? Yes, Munja? Any idea?
With the first one.
Yeah, the first one, y equals x to the power 7.
Oh, that will be 7x to the 6th power.
Very good. Very good, 3 of you. Excellent. That is correct. So dy by dx would be 7x to the power 6. Very good. What about this one? We did not talk about any formula of this type. We don't know how to deal with fractions. We don't know what happens when x is in the denominator. So I can rewrite this as x to the power minus 2. Very good, Haris. Excellent. Okay. So this is the equation now. Y equals x to the power minus 2. Dy by dx would be, this minus 2 would be multiplied, minus 2x to the power minus 2 minus 1. So this would be minus 2x to the power minus 3. Very good, Ishal. Excellent. Okay. So Munja, are you okay with this?
Y is called the root of x. So it will be x to the power half.
Yeah, very good. Okay. Y is x to the power half. And then dy by dx would be 1 by 2 x to the power whole power minus 1. So that would become 1 by 2 x to the power minus 1 by 2. Right? This would be the answer, but you can rewrite it as dy by dx equals 1 by 2 under the root x, okay? Because if under the root x is in the denominator, that would be with negative power. Very good, Haris, okay? And yeah, what about this one? I want all of you to try this one. Y equals 2. Yes, Munda, what do you think? What would be the derivative in this case?
0.
Very good, very good. Why it's 0? It's 0
The
because
constant.
if you follow the same concept, So we have y equals 2. It can be written as y equals 2 into x to the power 0. Okay, because x to the power 0 is basically 1. So I can always write it down this way. I'll write it again. This is the question, y equals 2. I can write it down as y equals 2 into x to the power 0. So we multiply this number. When we multiply 0 with any number, it becomes 0. So dy by dx would be 0. And this is the answer, right? So in general, the rule is that in case of any constant number, the derivative is 0. So d by dx of any constant number, let's say k, is 0. So even if we had y equals -2, that would have been 0. Y equals 1 by 2, that would have been 0. Y equals 4, that would have been 0, right? Because that is a constant number. So always remember the derivative of a constant number is 0. Anything that you did not understand? Yes, Ishal, Haris, and Munja.
Yeah, thank you, ma'am. I do understand.
Okay, very good. Now let's talk about two more rules and then we'll try out another question. So I'll write down the rules here. Okay, now the rule is that let's say you have been asked to derivate a function that has a constant with it. So it would be k d by dx into f of x. And similarly, let's say you have been asked to differentiate a sum or a difference where you have two functions of x. So that would be this. Okay, now I'll tell you. I'll give you some examples and that would help you with the understanding. Okay, let's say you have y equals 9x square. So far, we have been talking about the simple examples where we had x square, x cube, stuff like that. Okay, in order to differentiate this, I'll take this 9 out. So dy by dx would be the constant out 9 d by dx, and I will be differentiating x square only. So 9 as it is, how do we differentiate x square? 2 is the number. So I will write down 2x to the power 2 minus 1. And now I can just simplify this and it would give me 18x. Okay. So in general, in short, just remember, whenever you have any number that is being multiplied with the derivative, just keep it there and find the derivative with respect to x. Okay. You don't need to find anything about 9. Okay. There's no point in thinking about that. Yeah, exactly. You can just do it directly, Haris. Yes, you are right. Okay. You can do it directly as well. I was just doing in steps just so you're able to understand it that why it's 18x, but you certainly can directly multiply 2 with 9 and write it down as 18x. That's not an issue. Okay. So this was the example for the first rule. And for the second one, it is, let's say you have y equals x cubed plus x squared plus x. For this case, dy by dx would be derivative of this plus derivative of this plus derivative of this. So first we'll talk about x cube only. This is the old power that would come here, 3x square plus this number would come here, 2x plus 1 is the power, so 1 would come here and it would become 1 only, right? So x to the power 1 minus 1 is 0, and that is the answer. Now, these were two simple examples for these rules, but I guess you guys are already comfortable with this. So let's talk about the example about it. Okay. So it says, and I want you guys to try this out. Differentiate 3x to the power 4 minus 1 by 2x square plus 4 by under the root x plus 5 with respect to x. Now this is the question and you need to differentiate this. Okay, so I will give you 2 minutes, just do it and tell me the answers, okay? Yes. Yes, Munja, what is the answer?
I found 12 cubed plus 2 over x minus 2 square root of x.
Okay. And what about Haris and Vishal? Okay. So if I talk about the solution, okay, so it's 12x cubed, x to the power minus 3 minus 2x, and then minus 3 by 2. Okay, let's see what exactly it becomes. Yeah, I got it, Haris. Okay. All right. So this is the first term. I'll differentiate this. So I can write it down this way, that I have been asked to differentiate this expression now. I'm writing this whole thing because they did not say this is y equals this, right? If this was given, I would have just written dy by dx. So don't get confused with this, okay? And how do we do it? So 3 is going to be staying there as it is. 4 would be multiplied x to the power 3 minus, okay, now what exactly it is? I can rewrite it is 2x squared or raised to the power 4. It is 2x to the power 2, okay? So yeah, I'll first rewrite the question. It is 3x to the power 4 minus 1 by 2 x to the power minus 2 plus 4 x to the power minus 1 by 2 plus 5. I have written this again just so I have all the x in the numerator, and then I can use the power rule directly. So I'll refer to this one again and again. I'll rub this and I'll write down the derivative directly. So it would be dy by dx. Let's say this is y equals this, just to make things simpler. Okay. So it would be 3 is gonna come as it is multiplied by 4x cubed. Okay, minus into minus 2 would become plus 2 by 2 x to the power old power minus 2 minus 1. Okay, now plus into minus 1 by 2 would become minus 1 by 2 multiplied by 4 x to the power minus 1 by 2 minus 1 plus this is a constant, so the derivative would become 0. All right. And now I'll simplify this. 3 into 4 is 12. X cubed, this and this would be cancelled. Plus x to the power minus 3 minus 1 times 2 times 2. X to the power minus 3 by 2. So this is going to be the answer of this question. Okay, this is how we differentiate a mixed expression. Okay, this was simple. Let's talk about another example. So this time around, the question says, find the gradient of the tangent to the curve y equals x, 2x minus 1, x plus 3, at the point 1, 4. This is the question. Okay. Now you need to find the gradient of the tangent to the curve this at this point. Now this is why I explained the basics of differentiation in the very beginning of this chapter. Now they want you to find the gradient of the tangent to the curve at this point. Now let's say I'll draw a random diagram. Okay, so it would be something of let's say of this type. Okay, and the point 1, 4. So let's say this is the point. Okay, I'm just giving you a random example. I'll make the tangent. So they want you to find the gradient of this orange mustard line. Okay, now how do I find the gradient of this orange mustard line? Yes, this is a line, so I can just pick up 2 points and use the formula m equals y2 minus y1 divided by x2 minus x1, but that would be very time taking. So I will find the derivative of this curve and then I will plug in this 1, and then that would give me the gradient at this point, which would be same as the gradient of the tangent line. So this is the idea about it. Okay, now let's start the working. Did you understand the concept, like what exactly we are going to do? Obviously we will be differentiating this because this is what the chapter is, but the idea, the understanding of the idea is more important. Okay, and what about you, Haris and Munja? Please tell me quickly.
Yes, so far I understood, ma'am.
Okay, very good. Now, how do we differentiate this? Okay, so if I talk about the solution, I have y equals x into 2x minus 1 into x plus 3. Now, I have not discussed how to differentiate something of this type. Yes, we have seen when we have a constant that is being multiplied with x square, stuff like that, but we don't know how to do when we have three functions that are being multiplied and they have x in it. Okay, so first thing is to simplify the equation, to expand the equation and make it look like the type, we know how to differentiate. So I'll write it down this way. Y is, I'll keep x that way. Let's just expand the other two things. So 2x minus 1 would be multiplied with x plus 3. 2x into x would be 2x square. 2x into 3 would be 6x. Minus 1 into x would be minus x. Minus 1 into 3 would be minus 3. Y would become x into 2x squared, that would be 2x cubed plus 6x squared minus x squared minus 3x. Okay, now I know how to differentiate this. Okay, so I want all of you to differentiate this and then plug in the value of x and find the gradient of the tangent at this point. Yes, please do it. Okay, first simplify this and then do it. So I already got one answer. Yes, Ishal, it's close. Check that again. Check that again. There's just little difference in your answer and my answer. But I guess that your method would be correct. Just check that again. Yes. Okay. So first we'll find the derivative, that would be dy by dx. And now I'm going to differentiate this. I'll just simplify this. This would become 2x cubed plus 5x squared minus 3x. Okay. Now, let's find the derivative. So this is 2x cubed, 3 would be multiplied with 2, 6x squared, 2 would be multiplied with 5 plus 10x, and it has x to the power 1, that 1 would be multiplied with 3 minus 3. This would be the derivative. Now this is the derivative. We are interested in the gradient. So gradient is basically at a specific point, and I will plug in the x coordinate of this point in order to find the gradient at that point. This is a general expression. Let's say this is the curve. The x coordinate at this point is 1. It's 2 at this point. It's 3 at this point. It's 4 at this point. If I am interested in finding out the gradient at this point, I'll plug in 4 in this. If I'm interested in finding out the gradient at this point, I will plug in 2 in x. So that is how the gradient would keep on changing, but the general function would be the derivative. Okay. So dy by dx is going to become 6 into 1 square, since I'm interested in finding the gradient at 1, 4. So I'll plug in the x coordinate, that is 1 plus 10 into 1 minus 3. That would become 6 plus 10 minus 3. And the answer is 13. So this is the answer. So Munja, Haris and Nishal, did you understand this example?
Yes, ma'am.
Okay. All right. Now let's talk about another example, and then that is it for today. So please be very careful while understanding this one. It's very important. So it says the curve y equals ax to the power 4 plus bx squared plus x has gradient 3 when x is 1 and gradient minus 51 when x is minus 2. Find a and b. This is question number 2. Okay, now what exactly it is? Let's understand this. The curve y equals ax to the power 4 plus bx squared plus x has a gradient 3 when x is 1 and gradient minus 51 when x is minus 2. Now I think this much of the understanding is enough about the question. Let's not make the diagram and try understanding the example every time. Now we should get good enough and try solving the example directly, right? So the thing is that again we have two pieces of information. So we have that the gradient is 3 when x is 1 and the gradient is minus 51 when x is minus 2. Just like the previous chapter, I used to underline the keywords, I used to underline the important pieces of information just so we could make the equations, and then we used to find the first term and then the difference, right? So same is the concept here. I've underlined two important things. I'll make up two equations using that, and then I am going to use those in order to find A and B. So the gradient is 3 when x is 1. So let's just find the gradient for x equals 1, and then I'll equate that to 3. So dy by dx would basically be 4ax cubed plus 2bx plus 1. Without any doubt, this would be the derivative, okay? Now the gradient would be, when I will plug in the value of x as 1, so it is 3. They have told us the gradient is 3 when x is 1. So I've plugged in x equals 1, and this is what I'm getting. This is the first equation. The second equation would be, again, when I will differentiate this, I would get the same function. I'm just rewriting that over here. Now the gradient is minus 51 when a is minus 2, or when x is minus 2. Okay, minus 51 equals 4 into minus 8, and that would become minus 32a minus 4b plus 1. And I'll take this one to the other side, and it would become minus 52 equals minus 32a minus 4b. Now I can take 4 out from both the sides, and this would become minus 13 equals 8 minus 8a and minus b, right? And then I can take minus common on both sides. Minus and minus would be cancelled, and finally it is going to be 13 equals 8a plus b. This is the second equation. Now I have two equations. I can solve them simultaneously in order to find the values of a and b. I'll make b the subject. b equals 13 minus 8a, and I can use this in the first equation. So that would be 3 equals 4a plus 2 into 13 minus 8a plus 1. 3 equals 4a plus 26 minus 8a plus 1. So 3 equals 4a minus 8a minus 4a plus 27. And now I'll take minus 27 to that side. So it would become minus 27 plus 3 equals minus 4a. Yeah, Ishal, where exactly are you saying 16a?
2 by minus 8a.
No, which step exactly?
The
Down.
second step where 13 minus 8a is in the bracket, and then aren't you supposed to multiply it?
Mm. 1, 2, 3.
On
the
this
third
side?
step.
On this side
No,
or on this
on the
side?
left,
On
left
the left
side.
side. Okay, and
Like the third step,
the third
Yeah.
step, this
isn't it
one.
supposed to be 2
Okay,
into
16.
8a?
Yes, 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 yes. I got it. Thank you
Mm.
so much. Yeah, yeah, yeah. Very good. Yeah. Sorry about that. Thank you. Okay. So it would be minus 16a plus 1. Yes. So 3 equals, and then it would be 27 minus 12a, and I'll take 27 to that side. So minus 24 equals minus 12a, and a is going to be 2. Very, very good. Okay. Now a is 2. I can plug in the value of a in this 8, and I would get b equals 13 minus 8 into 2, and that would give me minus 3. So this would be the answer. So B is minus 3 and A is 2. Very good, excellent. Okay. So you guys are already good at solving equations simultaneously, and that is okay. But how to make those equations, that is also important, right? So whenever you have some important keywords in the question, try underlining them and try finding out the equivalent equations. Okay. Once you have your equations, you can easily just solve them simultaneously and find the values of the unknown variables. So any doubt in this one, anything that you did not understand? Okay, so I will stop